Okay, we're going to look at example 4 now. We're going to decide if it's a discrete or continuous graph, and we're going to graph it, and then we're going to determine if it's a function or not. Okay, so the first thing that we need to graph is our years are going to go along the bottom of the graph, and our the number of employees are going to go on the side. So I'm just going to move it up because I ruined my other graph. So we're going to start with this graph right here. So we're going to start right here, and we're going to count by fours. So this is 0, 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. So I started with 0, you guys, and I worked all the way up to 40. Now, there isn't enough room. So we're going to try to kind of cram it in. This is 2004, 2005, 2006. You guys, you don't have to put those lines, but I'm trying to make it neat for you because the first time I did it, I'll be honest, it looked horrible, and that is why I'm doing it again. So now what we're going to do is we are going to graph the points. Okay, so you guys, anytime they write it as 2004, 2009, this is 2004, 5, 6, 7, 8, 9. They go in order. So if we look at this graph, and you guys, the nice thing is that your numbers are right above your graph. So in 2004, we had 25 employees. So we're going to go 2004, and we're going to have 25 employees. It's going to be really close to that 24. And in 2005, we had 28, so we're going to go up to 28. In 2006, we had 34, so I'm going to go with 2006, 34. 34 is going to be somewhere between 32 and 36. And let's see, 2007, we had 31. So 31 would be close to right underneath 32, almost there. 28 would be 27. 2008 would be 27. So we're going to be really close to that 28. And in 2009, we had 29. Again, we're going to be really close. So now the question is this discrete or continuous? Well, since we didn't connect the dots and it didn't say to, and I should say not dots, since we didn't connect the points and it didn't say to, this is what we call discrete. Okay? It's not a curve. The other thing that this is because none of the domains repeat, and that's these years. Since none of the domains repeat, this is a function. So this is a discrete function. Again, it's discrete because the points are not connected, and it's a function because the domain does not repeat. Okay, so we're going to do example 5 now, and we're going to look at the difference. And you guys, there was no line. It just had us plot some points. So because this just had us plot points, that's why it's discrete. So we're going to look at a different graph now. We're going to look at graph y equals x squared plus 1. We're going to determine the domain and the range. And then we're going to determine whether the equation is a function or is one-to-one. If it's onto, both or neither. And then we're going to state whether it's discrete or continuous. Okay? So, how would we do this? So let's make our own x and y. Our graph looks like it only goes up to let's see, -6. So we'll start with -2, -1, 0, 1, 2. -2, and we're going to take it and we're going to plug it into here. So -2 squared would be 4. 4 plus 1 is 5. -1 squared is 1. 1 plus 1 is 2. 0 squared is 0. 1. 1 squared. So this is 2 and this is 5. So we're going to graph it. Over -2 up 5. Over -1 up 2. 0, 1. Then 1, 2. And then 2, 5. And you guys, if we went out 3, we would have gone up to 9. And then we're just going to... So, because it's a smooth curve, and it should really intersect, and yeah, I'm a horrible grapher. This is definitely continuous. Miss Fleury, why did we connect the dots on this one, but we didn't connect them on the last one? This one is because it's y equals x squared plus 1. It's actually giving us that graph, where the other one was just plotting these points and giving it a graph, a visual effect to it. So this one, you guys, I want you to think about what the domain is. So the domain would be, believe it or not, all real numbers. And it's all real numbers because you can put any number in there, you guys, and it will work. And then our range is going to be that lowest point. And our range is going to be greater than or equal to 1. And if you notice, because 0 is 1, so the lowest thing is we can get is 1. And because the domain matches perfectly, this is going to be an onto. Can you guys see that? No? Why didn't you tell me? Oh, because you're at home. That's right. So again, you guys, the reason we connected it is because it said y equals x squared plus 1. And whenever we do that, I made a chart so I would graph it. But you guys, the only reason I made this chart was because my graph wasn't that big. Remember, your domain, you can pick any number to be your domain, and it's fine. But you can't pick any number to be your range. Your smallest range is going to be 1, so it can be greater than or equal to 1. And because the domain fits perfectly, right, it's each element of the range corresponds to an element of the domain. So each range corresponds to this. It's an onto, and you guys, it is also a function. Anytime your parabola or your graph opens up, you guys, it's going to be a function. Okay, I think we're ready for the last part of our notes. I just have to find them because I wrote a lot of good stuff down for you. You're like, no, you didn't. It's okay. We're almost done, you guys. Almost done. So this is called function notation. G of x, f of x is function notation, and it replaces the y, and it said f of x. So you guys, basically, whatever the number is that we put in here is what we replace with. You never do anything with this. Never. You leave that. You don't touch it at all. So basically what it does is that this number tells us what we want to replace x with. So I'm going to write g of 2.8. That's how you say it, g of 2.8. Basically what it means is, hey, put 2.8 in for x. You guys, I'm going to write that one down there. So we're going to put 0.5, 2.8x, 2.8 squared. Okay, guys, here we go. So 2.8 in for x minus 5 times 2.8 plus 3.5. Okay. Again, we're just going to leave this. Just leave it. Just carry it down. You never do anything to that side. I just want you to know I am doing this in my calculator. Remember, this is 0.5 times 2.8 times 2.8. I got 3.92 here minus 14 plus 3.5. I got negative 6.58. How did you guys do? What did you guys get? So that means when you plug in 2.8, you get negative 6.58. So you guys, if you were to graph this and you pick this as your point, so this would be a point. So you would graph it as 2.8. You would go over to 2.8, down to 6.5, 6.58. That's a point, okay? So that's your final answer. You're good. Now let's do number 7. Number 7 says g of 4a. You guys, all it means is replace x with 4a. So I have 0.5 times 4a squared minus 5 times 4a plus 3.5. Okay. So you would have, I'm going to drop the 0, you guys, because sometimes that 0 confuses me. So I'm going to do 0.5 times 4a times 4a. Okay. And the reason I did this is you don't have to do it in your notes. I just want to show you why I'm getting this answer. So 0.5 times 4 times 4 is going to be 8. So we're going to get 8a. A times a is a squared. Minus, so I just showed you this again, okay? You don't have to write this step. I'm just showing you how I got 8a squared. 5 times 4a is 20a, and then plus 3.5. That's your answer. That's all you can do, you guys. This is your final answer. So when x is 4a, this is your answer right here. So I think that does it, okay? So if you have any questions, just let me know, okay? Bye-bye, guys.